Good morning or afternoon, as the case may be. This is Team Das from India. The team consists of Prasenjit Das, a computer engineer by profession. His glider flying experience came in useful in refining the configuration on X-plane. And apart from that, his computer wizardry, he was the coordinator for the project and provided the Bolshevik element in idea generation. Pradyut Das is a retired mechanical engineer who cut his engineering teeth on the fallen Gnat and the HF-24 Marut and was the reactionary member of the team. Kuntal Biswas is an aviation enthusiast who is the new member of the team. The renderings that you can see were done by him. Before I begin on the presentation, let me express on behalf of the team our sincere thanks to the Royal Aeronautical Society. Discussing aeroplanes is always interesting, and to design in detail for a competition was pleasure indeed, and a case of the labor we delight in physics pen. Before I proceed to discuss the design, I will put down the soft pillars, if you will permit the structural outrage, on which this uh, engineering of the aeroplane depended on. They were: one, the design of electric flight is not simply a matter of replacing one propulsion system with another. It is more like converting a design, say, of a metal casting to one in plastics. There are advantages to be gleaned and exploited, and cautions to be circumambulated. Some of these differences in electric flight versus internal combustion engine propelled flight is that there's no shift in the CG with consumption of energy. The gyroscopic inertia of the motor is much lower. It is possible to locate the heaviest single item, which is the battery, directly on the CG. I hasten to add, this is not a new idea. Herbert Smith had the same idea 100 years ago or more on the Sopwith canal. The cooling drag, often as high as 30% of the total drag of certain World War II aircraft, is negligible in this case. And the compact, clean motor allows for much cleaner cowling and consequently greater forward visibility. The benefits of the above, particularly with respect to the design of an aerobatic trainer aircraft, need not be elaborated. I will also pause at this point to point out that, contrary to the reactionary view of an aerobatic aircraft flying through a routine, the opposite view is a more dynamics of a particle approach, and therefore an tendency to drift towards monoplane layouts. The Our feeling was that the lower cooling and cowling drag could be, we felt, traded for the higher biplane drag to give us both a good light, large wing area and a good SCP. The second pillar was to look at the old solutions to old problems transferred to the new problems of today. Electric flight power to weight ratios are close to those of the World War One. The biplane was thus almost an automatic choice. The third pillar on which the design was based was a respect for financial and time constraints vis-a-vis advanced technology. I put to you the case of Lindbergh's Spirit of St. Louis. Suppose we could teletransport our knowledge back to 1927. How much could we have done to help Mr. Lindbergh? Maybe a town entering or a NACA cowling with a 5 miles per hour gain on cruising speed. Let us now tighten the turn a bit. Suppose we could, along with our knowledge, we could also transport the technology and the equipment. Of course, the aeroplane would be better, and Mr. Lindbergh would arrive over Le Boucher in the afternoon, but it would be a big victory of sorts because Mr. Lindbergh or his backers would not be able to afford the technology even if time constraints had permitted it. What the examples I have given attempts is there is a knowledge boundary layer where if we apply high tech into low tech situations, it may be wonderful, but it will be also wasteful. With all that as a background, I will digress and say we did examine a monoplane layout, which is now shown. It is the Stingfire, but in our evaluation, the biplane was deemed superior. Now, coming to the Hawkmoth, which is our submission, we started with the Bucher Jungmeister with its power loadings and wing loadings, and then we redesigned the fuselage to have side by side seating for the better teaching environment. Starting with the best man of 1940s, this has been confirmed for it continued to the Lightning T7 and the Jet Provost. The biplane layout without wire bracing resulted from a study of the Henschel 123. But at Prasenjit's insistence, the arrangement slowly evolved into a 1.5 plane. Not really a biplane, a Sesky plane, which came out from the results of the X-plane, which showed needs to refine the handling. The final results is as shown. Now I will close with the name. Hawkmoth, of course, celebrates two legendary bloodlines of this genre of aircraft, the Miles Hawk series and the de Havilland Moths, which had received universal acclaim through their physical presence, but by and by a cloud took all away. Thank you.